On this chapter, we are talking about the difference between two independent means. It is very important we realize here that these means do not influence each other. So you can't talk about a before or after idea. It is two means, such as we're testing the difference between boys and girls or freshmen and seniors. We're looking at two means that don't interact with each other. So here they have a 97% confidence interval. And if you notice, it's the true mean difference between beef and meat. I believe we're talking about fat content. So the true mean fat content for beef minus the true mean fat content for meat. Since this number here is positive, this interval, that tells us that beef was higher, because this interval is what we're creating with this difference. So think about this. We're saying that the true mean difference between these two for fat content is contained in the interval 1.3 to 4.3. So it probably means that we have evidence to suggest that beef hot dogs is higher. Because this interval is positive, take 10 minus 8 and you'll get a number of 2, which is near the center of this interval. I guess 2.5 is, I'm trying to estimate it in my head, the interval length is 3, so the center is 2.8. Remember, you can always get the center of a confidence interval if it's symmetric by taking half the length of the interval, which is 3, and then you can add that to the lower or subtract it from the upper. The length of this interval is 3, so the center of this interval is 2.8. 1.3 plus 1.5 is 2.8. 4.3 minus 1.5 is 2.8. Always good to know, so the margin of error is 1.5 for this interval. What does the fact that the confidence interval doesn't contain 0 tell us? Well, that's very important. So there actually is a significant difference. So the difference in the two sample means is significant. It's also important to note here this is a 97% confidence interval, so that'd be the same as doing a two-tailed test with a 0.03 alpha. The confidence interval is the same as doing a two-tailed test with 1 minus alpha for the confidence interval, or simply, if you think about the alpha as the remaining end of the confidence interval, 3%, that's your two-tailed test, if 0 is not in there. If we use this confidence interval to test the hypothesis that mu, I was actually answering the next question, I didn't even look. There we go. It's a great question, it's important to always notice. It's just the same as doing a two-tailed test with a 3% alpha level. Very important to notice that right there. The scores on a standardized test for 313 students in non-traditional math classes were compared to the scores of 276 students in traditional math classes. Right here we get N1 and N sub 2. Computer software is used to calculate the confidence interval, so it gives us it down here. This is a rather wide confidence interval because it's a 99. And if you notice, we see the confidence interval is more negative, so we have mu non-traditional minus mu traditional. So mu non-traditional would be lower because the confidence interval is more negative, because the actual difference that is observed between the two means would be somewhere down here. Let's figure out the actual difference. The actual difference would be the center of the interval. So what I'm going to do is I'm going to add together those two numbers, and then I'm going to divide by 2, and that gives me the margin of error. And now to find the actual center of this interval, let's take the lower, which is negative 3.788, and add to it 2.988. The question doesn't ask this, but the center of the interval is now negative 0.8. So we could write this interval as negative 0.8 plus or minus 2.988. It's a good way of writing the interval, and we could have just written it out that way to start. If we had created a 98% confidence interval, the interval would be smaller. Think about things like this. What are you 10% confident you'll make on the next test? You might say, well, an A. What are you 99% confident you'll make? You might say, well, I'll pass. So your interval got wider as we went out further away and gave more confidence. Does this result suggest that students who learn mathematics so significantly, and it's going to be no because the interval contains 0. So no because the interval contains 0, and that's all I need to read. The results are not significant because we can't conclude there is a difference because we're saying 0 is a possibility. So since 0 is a possibility, well, non-traditional could be doing worse, or it could be doing better, or it could be having no difference at all. We don't know. We're 99% confident the difference is contained in this interval, but the difference could go multiple ways. Aha! So you can do this by hand, and I suggest doing this by hand. You'll need to use, it's in the tip, and I have it over here on this screen. You'll need to use the degrees of freedom calculator, which I'll show you how to use here. So we'll bring this up and use this for this problem and talk about what to enter into your screen. So let's go ahead. Degrees of freedom calculator right here. So with this problem, bring up the problem. A commuter wants to determine if route A is faster than route B for getting to work. Each day he randomly selects a route to take until he drives the route 20 times. So n for each one is going to be 20. Route A averages 42 minutes with a standard deviation of 2 minutes. Route B averages 44 minutes with a standard deviation of 3 minutes. So we can use the calculator over here on this screen. He's going to drive each route 20 times. And the first one has a standard deviation of 2, and the second one has a standard deviation of 3. So we need to go here and put in 20, 20, 2, 3, and compute the degrees of freedom, 33.1031. So we can go back to our t-applets now, always good. So here's the t-applet right here, and we can put in, let's go over to the t-applet on stat distributions, and put in 33 degrees of freedom. Will it let me do 33.1? It will. Nice applet. Good deal. So let's put in 33.1 to be a little bit more exact. So we can do this by hand right here. It's not too crazy to do. I suggest always doing these by hand. What you'll need to do to run this test is go down here. Let's see if they want an interval or a test. They want a confidence interval. So let's go up here to our confidence interval. To make a confidence interval, we need to do the true difference between the means, the observed difference between the sample means. We were making a confidence interval for the true difference between the means. We're going to use the observed difference, and for this problem, that will be, let's see here, route A is 42 minutes, and look at what they do to you. They put B minus A. This is ridiculous. It makes this problem harder than it is. But if you don't do B minus A, you will get the problem wrong. So we need to take B first, which is 44, and then A, which is 42. So you put 44 here, 42 there. The observed difference between the means is 2, because 44 minus 42 is 2. The only hard part is solving this down here. We saw that this was 3, this was 2, because, am I getting that correct? Yes, because this would be route B, and this would be route A, and then it really doesn't matter because n is the same for both of them, so it doesn't matter if you switch around which is which. You solve out right here, and you will get a small number, and then you need to put that back up here and times it by the t-statistic. We're just showing you right now where all the parts of this problem are at. Please do this by hand. The calculator is one thing, but doing it by hand is another. We need to make a 95% confidence interval, and let's see if this changes ever so slightly. It doesn't. Okay, good. It looks like this will be close enough to the right answer that it will work, 2.035. And that will be your t-statistic. It's like the 1.96 we would use for a 95% confidence interval. Let's double check, 95%, yep. So you'd put in that 2.035 right up here, 2.035. You'd solve down here, plug that in right there, and then it'd be 2 plus or minus, and then the margin of error. All confidence intervals have 3 parts. What you're trying to estimate, we are trying to estimate the true difference between the means using the sample or observed difference between the means. Then we have this part right here, which is our confidence level obtained from the t-distribution. And then we have some sort of standard deviation or standard error, which is the last part, part 3. You can also think of the center of the interval, and everything after the plus or minus is your margin of error. So let's go back and do this with the calculator. Haha. So you want to grab your TI calculator. You want to go to Stat, Tests, and scroll down to, what do we want to do here? We want to do a 2-sample t-interval. 2-sample t-interval, which is number 0. 2-sample t-interval, and go over to Stats. Now this is where it's confusing. We want to enter in B first. So our mean was 44 for B. Let's see here, our standard deviation was 3, and our sample size was 20. Then we get down to the first one, route A, which was 42, 20, and 2. 95% confidence interval, pooled no, and hit calculate. And it'll give us the interval right here, but always practice doing these by hand. Always, always, always. And it looks like I entered in one thing incorrectly in my calculator. Let me go back to T interval, to sample T interval. I see what I did. I was saying it all correctly, and I misentered one thing. This is why we do it both ways, and I can't stress that enough. You really need to practice doing it both ways, because I knew from doing these problems multiple times that my answer was wrong. I got humongous numbers, but I made one miscalculation in the calculator, and everything looked wrong. So if you don't have a lot of practice, you might not notice these small, subtle differences that indicate to you a problem. That is why we practice this. This problem right here, a lot of people just skip over it or guess because it's only 2 points. But this one right here is great to practice with. Use the formula to make your confidence interval. Check it by doing the formula and then check it with your calculator. If for some reason your answers disagree, you want to go over and redo the calculator, redo the formula. But easy points on the test if you practice up, because this problem looks long, but all it's telling you right here is we have sample size for each, we have standard deviation for route B, standard deviation for route A, we have the mean for route A and the mean for route B, making 95% confidence interval. It's a 2-sample T interval where the means are independent of each other. Now this last one right here is probably best done in JUMP. These lists are really long, and so I'm going to suggest doing this in JUMP, but you could do it in your calculator just by going in and entering in everything and then go to stats. Let me see here. So you can enter in all of these lists into your calculator. So once you go to 2-sample T interval, you will go to data and you need lists all entered in. So you can do this if you want right there. It'll calculate it for you with the data, but we are going to see how to do it in JUMP, which is a bit quicker, but you don't have JUMP on the test. So with this in mind, let's go to make tab delimited copy right here. That just said it made a copy. I'm going to open up JUMP. I have JUMP 11. It's really not that awesome. I haven't been too impressed. I like JUMP, and I was like, oh man, it's going to be like way better. And it's been virtually identical, except they've changed where a few things are at. I still love JUMP. Okay, so I'm using Control-Shift-V, which pastes with column names. You can go to Edit, Paste with column names. If you see any wackiness in here where maybe there's some quotes, then you need to bring it into Excel, paste into Excel, copy from Excel, and then paste back here. You should not see it, so let's view that process really quick. If you see some wackiness, go into Excel, paste, and then copy out of Excel, and then bring it back to JUMP here and paste it back in. So make sure it looks like this. You should see blue right here. We want to go to Tables, and we want to go to Stack. We're going to go to Stack both of these, and we're almost done, because now we have a label, and we have the data. So we want to analyze, and let's go to Fit Y by X. We're going to see if the cereal label can tell us anything about the sugar content. Right there. So it definitely looks like there's a difference going on here. Let's go ahead and go to t-test. And right here you'll see it. We have a confidence interval for the difference. And it's kind of good to get used to some JUMP output because you can see what's going on here. We expected the difference to be 0. But we observed a difference of 35.7, which is a huge difference. But it's not just huge in terms of, oh, well, 35 is huge. Because think about this. What if I talked about M&M factories and how many M&Ms they make a day? Well, they probably make millions. So what if I told you one factory makes 35 more M&Ms? You'd be like, well, that's not huge. So with this in mind, we need to put that in terms of standard errors of the mean. What you do to get the t-ratio right here is as simple of, let's look at the test, the difference right here, and ignore this delta, that's just 0. The difference over the standard error is the t-ratio. And you can see that right here. Difference over standard error is the t-ratio. If you just divide these two numbers, you will get 16.78. And then if you notice, the area to the right of this is so tiny. We can hover over this and it will display it. It's 0.0000020 zeros 832. It's tiny. But more importantly, we notice here that jives with it that 0 is not contained in the interval. 0 is definitely not in this interval. So we see it even says it now. It says like check to see if it contains 0. It's like if 0 is not in there, check if the confidence interval contains 0. Wow, Jump tells you a lot if you got to swirl over it. It's so weird, and then it'll tell you the actual p-values and stuff. So we do see a difference. Let's go back to the homework, and I'm going to be switching around here a little bit. Let's put the jump by the side. I'm going to put it over here so I can actually click back on it. So the confidence interval goes from, we want to put the lower in first, 31.46 to, and let's go to the higher one, 40.05. Definitely. So with that in mind, we definitely do see a difference. You know, there's some interpretation you could do here that, is this a significant difference? Well, yes, oh, totally it is. Because 0 is not contained in the interval, we definitely have a significant difference. It looks like children's cereals. If we go back to our jump output, since this is children's cereal minus adult cereal, we're talking about a positive difference here, meaning children's cereal have way more sugar in it than adult cereals. Good luck on this and practice up and know the similarities between doing tests and doing confidence intervals. As always, you could have done this as a test. Let's go to the output right here. You can run this as a test. So try getting your t-statistic right here and then use the t-distribution to in turn run that test and get the p-values. If we wanted to do this, we can bring the jump output up right here. It's going to be so tiny. The t-statistic is 16.7. The degrees of freedom is 43, right about. So let's put that in. 43, and we need to put in here 16.7. And let's go ahead and do a right-tailed test. Is it true children's cereals have more sugar than adult cereals? Definitely. Is it true they have a different amount? Definitely. That the true mean difference is different. That's weird to say. So we have evidence we have a significant two-tailed test. We have a significant one-tailed test for greater than. We do not have a significant left-tailed test because that would suggest that the true mean difference is lower for children's cereals, that children's cereals have less sugar than adult cereals. That is not significant in these results, as viewable down here. And it's right in the orders. It's funny, the two-tailed, the right-tailed, and the left-tailed go in the same order on the jump output. Good deal. Practice up.